Okay, yeah, let's come to the sixth and final piece of our introduction session for fx-Calc. Our today's topic is function analysis, and I believe that's the most powerful and most interesting capability of fx-Calc, which makes really a difference if you look at your Windows calculator. So yeah, let's start with the topic itself. What is function analysis? It's basically to identify the characteristics of a function, and quite important to say is that fx-Calc is using numeric methods to identify those characteristics in a certain range, and this range needs to be specified. So that's a difference compared to CAS calculators, which perform kind of a analytic approach in order to find those characteristics. And therefore, those systems are not limited to a specific range, a specific interval, if you want. And another disadvantage might be that the calculation precision, the way how the calculation is numerically done, is always involving a remaining small deviation from the exact result. Yeah, so, but that's not a big deal because bottom line, this little deviation doesn't play a role in real life, and the numerical result is precise enough for almost everybody. So the advantage of using numeric procedures is, of course, that fx-Calc isn't limited to a specific set of functions or to a specific limitation of combination of functions and terms. Yeah, so fx-Calc is really capable of analyzing almost everything what you could imagine as a term which contains a function. Yeah, and that's maybe one of the huge differences to CIS systems, which have quite often a limitation in combinations of functions which can be analyzed. And um, worth to say, not each and every function can be analyzed at the end. Yeah, so from this point of view, a few disadvantages, but one big advantage. And let's start with examples. So if you look into our function database, we have here a test function, which is a cubic function basically. And let's have a look at this by simply clicking on fx-Analyze. The fx-Analyze window starts with an input area for our function, and most importantly, we have this lower limit and upper limit for the range or the interval that I mentioned already in the introduction to this topic. Yeah, so the analysis for this function is being performed within this specific interval, and any roots or any extreme points or any pull points, whatever, can only be found within this interval. That's the limitation of having numerical methods behind in order to get those characteristics identified and calculated. And as maybe always, or as we experienced this already earlier with other functionalities within fx-Calc, the handling is very easy, very intuitive, and yeah, there is really no reason to think about rocket science or topics like this, because you can easily click on this button here, full analysis based on default settings, and fx-Calc will perform a full analysis of this function here in this text field, and will provide you with the graphical result presentation. That means the function graph along with all characteristic points that have been found. We can do this for this example, which is a pre-installed example, which is always coming up when you open this dialog box. And we simply click on this button here and we see how it works. It provides you a view on the function itself. We have in black all those root points, yeah, so the points where the function is 0. We have the local extreme points in red, yeah, and we have pole points in green. And of course, we can again zoom in and make the picture a bit bigger so that it's more easy to read. You see the different function values along with all the other graphical plot presentations of the results. And you have again this graphic cursor which allows you to look up for specific values. For instance, for this local maximum here, we can then read the x and y values for this local maximum. Yeah, okay, that's maybe a little introduction, and our intention was to analyze this function here. Yeah, so in this case, we have to copy this function from calculator by simply clicking on this button. As already explained for function graphics, we have again here the possibility to use those inbuilt functions to yeah, adopt and change this expression yeah, up to our demand. And yeah, let's analyze this expression then again, but let's do it step by step now. Yeah, so the first part is roots, and I talked already about precision. You have here predefined precision of yeah, 1e minus 10, which is scientific numbering and says that we want to have a precision of 10 digits in our result. So by running the scan, we get 3 solutions for roots. Yeah, and the interesting point to mention here is that this isn't only solving roots. You could as well define a target value here, so you can make a target search by, for instance, saying, okay, my target value should be 7, and run the scan again, and the solution for this target value would be 3.258. Yeah, so quite interesting functionality, I would say. So that's what I have to say about roots. Then we have the local extreme points, and this works again quite similar. The only thing is that the precision is down to 5 digits here, and the reason behind is that the calculation mechanism is working with those differential quotients, and this of course requires a little lower precision for stability reasons. Yeah, I can of course increase this for this quite simple function. Yeah, that's not a problem at all, and I get the maximum and minimum calculated. So the precision, by the way, can always be adjusted by using those sliders here. Another maybe interesting topic is really that there is a number which specifies the scan steps that will be performed in order to analyze the range that we defined at the beginning, which is again represented here, and we can change it here as well if we want. Yeah, so for the moment we scan 10,000 values within this range, but you could increase it, of course, but it really would mean, yeah, that with increasing the number of interval ticks, yeah, you of course then have to expect a longer calculation, yeah, duration. Okay, then the next tab is about pole points. The pole point calculation is to a certain extent partial analytic, because it needs to analyze the expression in order to find the terms in the expression that would lead to pole points, and is then analyzing the roots for those specific parts of the expression. So then we have the possibility to calculate a definitive integral and yeah, again we can apply here our range values for lower limit and upper limit. And we have a possibility to calculate with yeah, tangent equations. I will make this a little more detailed example maybe here. Let's take another starting point. Let's take 6.6 as a starting point, calculate this. And what you can do here is really to yeah, perform a Newton iteration, yeah, because you simply click on this button and the calculation will take over the solution for this tangent equation, and we'll use this as next point in order to iterate the solution for this function itself, which is quite close. Yeah, so if you click on this button, you see after 5 steps we are almost done. Yeah, we have found the solution. Yeah, and bottom line, we can then compare the solution, for instance, with our root values here. Yeah, so as you can see, we talk here about 2.4142, yeah, and if we look at roots, that's exactly what we calculated here, but based on another numerical procedure. Yeah, and last but not least, as already mentioned, we have this function plot, yeah, which provides us the graphical evidence of what has been calculated. It looks a bit odd for the moment, simply because of the huge function results again, and as we learned this already in an earlier session, we can limit the function plot to a certain result range, and by doing so we have now a much better picture of what it really is. Yeah, so that's basically the function that we just analyzed, and it has no pull points, just 3 root points and 1 maximum and 1 minimum. Yeah, and yeah, that's how it works. We covered everything that's currently possible based on fx-Calc. I think it provides a reasonable understanding of your mathematical expressions if you want, and can provide you some help with analyzing expressions that a CIS system might be not able to analyze. And the only thing I can say about it is play a little bit with it, to learn about it, to learn about the capabilities. And of course, there is other stuff that provides much more fun than mathematics. I know. But at the end of the day, I hope it saves you a little bit time to do exactly this other stuff. And with those last words, I want to close the tutorial session for now and wish you good luck. Take care and bye bye.